All right, welcome everyone. My name is Chris Woods. I'm an account executive here at Starburst based in Boston. I want to thank you all for joining us today for a webinar, Presto, Past, Present, and Future, and the Birth of Starburst. Today, you'll learn a little bit about Presto's origins and where the roadmap is heading. You'll also hear about how Starburst is making Presto enterprise ready. Leading the talk today will be Presto co-creator and Starburst CTO, Martin Traverso. Martin is joined by Starburst Solutions Architect and my friend, Sam Durkazarian. As a reminder, please use the question box to submit your questions throughout the presentation, and we'll facilitate a Q&A at the end of the session. We encourage you guys to download a complimentary copy of O'Reilly's Presto Guide, and I'll be including a link to that in the chat box. And without further ado, I'll turn things over to Martin to kick us off. Thanks.
All right, thank you, Chris. I'm going to turn off the camera here to avoid distractions. Just a sec. All right. So let me start with a quick intro to Presto in case, I assume people are familiar with it, but let's just go over it very briefly. So Presto is a distributed SQL query engine. We built it for speed and scale, and we've proven it at very, very large scale with thousands of users at companies such as Facebook, where it was incubated, and then other large internet companies that ended up using over the years. It's an open source project. It's been around 2012. There's a large and very vibrant community of developers across the entire world, developers and users actually. And if you're interested in that side of the project, you can find more details at the website, or you can join the Slack channel to engage and discuss with other users and developers. So unlike traditional database, Presto decouples the computation and storage. So the compute engine, the query layer, is separate from the storage layer. That makes it possible to scale both layers independently. You can scale the computation based on the actual computation requirements. Based on that, you can scale your clusters up and down without having to grow the storage or manage that at the same level. It's also based on a plugin architecture that allows Presto to integrate with different storage backends, be it object stores like S3 or Azure storage system, or NoSQL databases like Elasticsearch, Cassandra, and so on, or even SQL databases like Postgres, MySQL, Oracle. And you can query data where it lives without you don't have to migrate or copy data from one place to another. So it makes it easier to write your queries without having to have complex ETL or other data migration processes. And then Presto runs anywhere. It can run on any cloud. It's agnostic about the environment. It can run on different clouds, different environments. It can run against different backends, different storage backends. So it makes it easy to migrate from one environment to another, so you're not locked into any particular technology. Presto is used all over the world, across companies large and small, and across many different industries. So there are companies from consumer, internet industry, to retail, manufacturing, financial companies, and not just in the US, but everywhere else in the world. There's companies in Europe, in Asia, in South America. So let's talk a bit about the history of the project. We started the project back in 2012. The team was Dane Sundstrom, David Phillips, Eric Huang, and myself. We were at Facebook when we did that. We created Presto originally with the eventual goal to open source it and build a community around it, which we did in 2013. And then since then, a bunch of companies and people started engaging with in the project. In 2014, a team led by Justin Borgman at Teradata, they started engaging with us and with the rest of the community, and they basically started focusing on commercializing Presto, and they became the first company that provided a commercial offering for Presto. Later in 2017, they left Teradata and they set up Starburst as the Presto company. It's a company dedicated to commercializing and advancing the Presto technology. In 2018, Dane, David, and myself left Facebook. We realized at that point the project has grown enough. It was time for it to become independent from a single company. So we left and spent a few months focused on full-time on growing the community, consolidating the community, and getting more people, more companies involved in the project. Then later in 2019, we joined forces with Starburst, and here we are today. So why do we build Presto? There's this famous, well, at least internally at Facebook, this famous quote that a data scientist said, at the time, if they could run Hive queries, they were having a good time, a good day when they were doing their work. Hive was the engine that almost everyone at Facebook used at the time to do analytics, and Hive is slow. It was mostly being used for ETL and data transformation processes, but because there wasn't anything else available, people use it for what you would normally think of as interactive or ad hoc workloads. But it was slow, so it was a bad experience. There was another system that attempted to solve that problem, but it was limited. It wasn't designed to scale or to be able to evolve in the ways that we need the system to evolve. So in good Facebook tradition, we decided to start a new project and develop a new query engine from scratch. And that's where how Presto was born. So we had a few goals. We wanted Presto to be fast, but also to produce correct results. People were typically traded. There was a notion that in order to be fast, you had to trade off speed for correctness in the results, which many systems did by just skipping data or sampling data and so on. We believe that wasn't the case, and we wanted to satisfy both requirements. Of course, we had to build it in a way that could support the scale of Facebook at the time and be able to keep up. The company kept growing over the years in terms of numbers of employees, and that correlated directly with the number of users using Presto internally. And we picked standard SQL as the interface, and this was because we believe that standard SQL, or a flavor of standard SQL, was what everyone in the world was familiar with. Everyone had used any commercial database or data warehouse. So by picking that, it would be easy for people to adopt and get used to using Presto. And of course, we wanted to make it open source. We thought, and we believe that open source software ends up being the most robust and software and then popular and successful software in the long term. And we wanted Presto to be there for the long run. And of course, by getting other people involved, other companies, we get a chance to build something that satisfies not just one company and one use case, but something that everyone can use and make Presto the best software in the long term. Let's do a recap of some of the things that happened over the last year and a half in terms of community and features. We have seen tremendous growth in the community. Right now, we have almost as of today, almost 2,600 people on the Slack channel. Keep in mind, we started back in January 2019 with 800 people, so it has grown significantly. These are users, developers, people are interested in Presto, people that want to ask questions, which, by the way, that's a good place to be if you want to engage with other users and developers. There's a lot of people interacting every day. We've seen so far in the project, 400 people have contributed code, and a larger number of people have contributed in other ways to the project. And in the last year alone, we've seen, or a year and a half alone, we received more than 5,000 code commits, which account for 25% of all the commits in the history of the project over the last 8 years. We've made a number of improvements across multiple areas, all the way from new language features, query engine improvements, performance optimizations, and security. A couple of the notable ones are that were added recently are support for variable precision datetime types, which allow Presto to process daytime data with higher precision than it did in the past. So now datetimes can have nanosecond or even picosecond precision, which are things that are important in particular for companies in the financial industry. Then there's dynamic filtering, which is an optimization to the query engine that basically allows queries that involve joins to run much faster. So if you're on a recent version, and you have that kind of queries, you may see significant performance improvements. We've also grown the list of connectors significantly. So we had a pretty good selection before, but over the last year and a half, we added connectors for a bunch of open source projects and commercial systems. One of the most popular ones is the connector for Elasticsearch. We also added recently connectors for BigQuery and Oracle. Right. In terms of what's coming up over the next few months, I mean, this is a roadmap that we put up at the beginning of the year, and one of the things to keep in mind, this is driven by what people are working on in the community, what people are interested in working on right now. There are a few areas involving performance, improving connectivity with different connectors or improving existing connectors, and adding more flexibility to the system. So a couple of the notable ones are around performance is the ability to do push down of more complex operations into connectors, which should make Presto much faster especially when talking to SQL databases or systems that can do complex operations underneath. And then there's a feature going on right now, in progress right now, to support materialized views, which can also improve usability and performance of the system for people that have data sets that are being queried repeatedly in the same way. And then we're also working on a revamp of the way Presto deals with functions to make the system more flexible. This will allow eventually for people to define their own functions dynamically using the SQL dialect or potentially other scripting languages. Right, and with that, I'll hand it off to Sam, who's going to talk about about Starburst Enterprise Presto version.
Hi, everyone. I hope everyone can hear me. It took me a second just to put myself off mute. So what I'm going to do is I'm going to walk you guys through sort of what is Enterprise Presto looks like, and talk a little bit about why we believe that the way Presto is addressing some of the challenges that exist today in the market is the way we think about that. So these are some of the things that I'll cover in my portion of the presentation. I'll talk a little bit about the data personas and their journey, about some of the existing methods for allowing end users have access to the data. I'll talk a little bit about the mind shift that is really driving some of the success stories in our customers, and also cover the use cases that we think Presto is well suited for. So before all that, what I'd like to do is just to take a couple of minutes, talk about the typical enterprise organization. And this is what we've seen sort of over and over again at different customers. I think this picture is probably holding true for many organizations in the enterprise world. So you typically have three types of personas. You have the business users from the line of business, data analysts, and support folks in DBAs and data engineering teams that are providing the infrastructure and the access to the data. And the typical flow usually goes from the line of business asking questions that would help them derive some insights to the data analysts. Oftentimes, data analysts do need to get access to the data, which in many organizations is spread across multiple different sources, and we'll talk a little bit about that. Obviously, the data teams work on providing that infrastructure and allowing the access to the data, which in some cases may take weeks or months. And then finally, obviously, being able to answer some of these questions for the line of business. By the time this cycle sort of completes, oftentimes those questions are either obsolete or there are new questions. So this is an ongoing process, and again, depending on the organization, it can be weeks or months cycle, especially if you consider some of the new data sources that are coming into play all the time. And so if you look at this, at the existing sort of landscape, and currently there are several methods that data teams are able to utilize in order to give access to the data for the end users. One of which is using some of the tools on the market. And so this is your typical BI tools or tools like Spark that allow access to the sources and essentially bring the data into the tool, allowing you to process the data inside the tool. And in some cases, because of the scalability challenges, there are servers that are part of the picture as well. The second approach is ETL, which really has been there for a while. This is not a new concept. It's been there as long as the databases have been around. But the concepts kind of became more about moving the data into a single place so that you can then get access to that data to analyze. And again, there's been an evolution from the data warehousing to the data lakes, but generally speaking, the concept remains more or less the same. And the third way is the ability to have a federated access where you have an ability to use a singular tool or a single platform that gives you an ability to federate across multiple sources that are typically present in the enterprise. And so if we look at some of the challenges, with a tools approach, you do run into some of these challenges, one of which is security. So you do have to maintain security in a sort of decentralized manner across all of those sources. Scalability can be very much a problem, especially as the data volumes are growing and the concurrency grows with many more users getting their hands on data. Making those tools scale becomes a big challenge. Standards is another one. A lot of these data sources, they have different flavors of SQL, access patterns, etc. So very few tools are kind of successful at supporting all of these sources in a uniform manner. And then finally, from security perspective, again, the need to distribute credentials to all of the users is a challenge. It just proliferates security risks throughout their organization. With the ETL, you have slightly different challenges, one of which is really the difficulty and the complexity of setting up these pipelines. So ETL is typically thought through as a pipelining from one source into another, and it does take time to set these pipelines up. It does take a lot of time to maintain them, so that's really one of the challenges here. The duplicated data is another one. You end up with a copy of the data. It does raise your costs of the infrastructure, but it also adds to the complexity of maintaining it, obviously. The third one I'd say here is the delayed data, because ETL usually runs on schedule. Sometimes it's event-driven, part of your pipeline, but in all those cases, you are behind on the data, and usually you have either weekly jobs, daily jobs, hourly jobs. In some cases, it could be 10, 20-minute jobs, but in all those cases, you still are working on an older data, and for certain use cases, it's just not sufficient. And then finally, no matter how great the data lake architecture is, what kind of data warehousing are being used, oftentimes you still have some data sources that just not fitting into the picture, and they're not part of the pipeline. This could be third-party data. This could be finance data that doesn't make its way oftentimes into the, let's say, cloud environments or some other scenarios, and so you end up with some data is just simply not accessible for analysis. And so with the data warehousing, you typically have this type of picture where you have a data warehouse or data lake and a variety of different sources on the periphery, that some of which may be part of the ETL and some of which may not. And the third way, or third method of granting access to the data is the federated access. And the difference here is that it is a single connection that is being set up, and through that infrastructure, end users are able to view the various catalogs, each one of which represents the data source. That's one. And the second thing is, as an ANSI SQL standard, that gives you an ability to interact with a variety of different sources in a single format and language, irrespective of what type of sources those are. And we'll talk a little bit about this later on. And Starburst supports a whole variety of NoSQL, relational databases, data lakes, JSON data, even unstructured data in some cases can also be processed in this manner. And the final thing is that adding new sources becomes a lot easier and much faster, because you do not have to set up any pipelines. Your only involvement with adding a source is to edit a configuration file that points to the new source. It's done once by administrators, and once that is in place, all of the users have access to that data. So in that regard, this is really the three major buckets of what Presto helps you solve, one of which is the data source problems. And this, again, is ability to add sources quickly without need to set up pipelines, ability to use a variety of different sources, which may be dissimilar, but they still are usable within the infrastructure, like Kafka being one of the examples. And the ability to use most recent data. So you're not having to wait for the data ETL process to finish. You're not dealing with failures during that process. It is all more or less done real time. The second part, of course, is the ANSI SQL part of it. We spoke about this earlier. There are a lot of flavors of SQL, and here's some examples here. And as far as the Starburst Presto is concerned, every user is only interacting with the engine using ANSI SQL. And the last thing here is the centralized access problem, which really gives an ability to use the platform as a high concurrency, low latency engine, even in the cases where, for example, some of the tools and dashboards generate automated queries. And as we know, they may not be most efficient queries generated. But Starburst has a lot of smarts in its cost-based optimizer, for example, that will fix these problems behind the scenes. So as far as the users are concerned, they're not feeling the detriment of these things when they work with the data. And finally, granting security becomes an easier, more centralized way of doing that, which really helps the data teams and the IT security teams to support a large number of users in the organization. So then, in simple terms, Presto is a distributed ANSI SQL engine that provides a scalable and federated single point of access to your data. And that's really what it's been built as Martin has sort of given the insights into the history of it. And it has been evolving along these lines since then. As far as the distributed nature and the concurrency, some of you may know, but just real quickly, the concepts behind Presto engine and its clusters is that there is a coordinator node that is responsible for accepting the requests from the end users, but then after a series of functions that it performs, it schedules the execution across multiple worker nodes. Each one of this having access to the data sources that are configured, therefore scaling sort of horizontally to perform these tasks. So as a result, going back into the data organization view, we see that the business users now can get much faster answers because once these sources are available, there is no lag between the time when they ask the question and the data analysts or data scientists being able to give them these answers. It's also making things much easier for the analysts because they do have access to the data through the standard SQL and across multiple sources. And for the data administrators, data engineers, and IT that supports, it becomes easier to add new sources as well as to scale. The scalability is a big part of Presto's design. It has, a really well thought through mechanism by which it allows a very efficient scalability. So adding new nodes to the cluster is very fast and allows to scale instantaneously almost. In terms of the connectivity, like Martin mentioned, there's a lot of connectors in open source. Starburst has added some and has optimized many of those connectors to boost the performance even further. So for example, some of the connectors that are available have been parallelized, and this gives an ability for those worker nodes to reach out into the data sources in a parallel manner. That obviously speeds up the data load times and overall query performance. There are some connectors here that are proprietary to Starburst. There are some examples like Snowflake, for example, which is a well-known data warehouse, cloud-based data warehouse. There's also a set of capabilities that allow for easier management on the security side with a user impersonation and pass-through authentication, where some of the sources already may have some users set up. And so Presto allows us to pass these credentials to the underlying source, making things easier on the administrator side. And then finally, some of the cost-based optimizations that are again available in some of the connectors, these some of them are still sort of proprietary to Starburst. A lot of them are being contributed to the open source, but Starburst is always looking for new ways to do the optimizations and bring some more efficiencies into the connectors. So just to talk a little bit more about the advantages, from the data analyst perspective, again, ability to have a single connection through the tool of choice, and any tool that supports ODBC, JDBC driver is able to connect to Presto cluster. That's a huge win. You don't have to use any specialized tools or any new tools to learn, no new languages either. The ability to automate things through dashboards, as well as the ad hoc analytics, and do that in a very performant and scalable manner. So typically dashboards are the type of use case that allows or requires a high concurrency oftentimes. And so Presto again shines at this. And lastly, in terms of the accessing the data sources, it is ability to do that through a BI tool or some other means of access to view all of the catalogs. And the new databases that are coming into play or being added into the infrastructure become available to the entire organization as soon as it is configured. These are some of the examples of tools that customers use. Some of them are BI tools, some of them are SQL tools, and this is obviously not the finite list. There are more tools. Like I said, anything JDBC or ODBC compliant can really access Presto cluster. So for the data scientists, the first thing I think to talk about here is, like, if you look at the data science day in life, typically the first step the data scientist needs to do is to take a look at the data. So when the new sources come into play, or when some of the existing sources are there, we'll look at the things to be able to understand how we can utilize this data. And that's the first step, even before building the models or training the models or deploying the models. And so that's what we call introspective or ad hoc analytics, really. So it still falls into that category. So from concurrency perspective, some of the tools that exist in the market are not ideal. And Spark, for example, is a great general purpose distributed engine. It does a lot of good things in the data science world, able to run complex algorithms with a variety of different languages. But when it comes to concurrency, it just doesn't do as well as Presto does. So again, when we talk about the concurrency models and the need to have very low latency, this is where Starburst Presto can help. Query multiple data sources is again a big thing. You know, if you are a data scientist, you know that the more data you have, the better chances that you would be able to utilize it. Of course, the quality of data matters as well. But you know, before you can judge the quality, you have to have access to that data. And even so, more important to have that access in a streamlined manner. So with Presto, you can federate across multiple sources using ANSI SQL all in one query. And that's just much easier, much more scalable than having to move the data from one place to another, load it into the tool, and then try to join that within the tool, which in some cases just simply wouldn't be able to process that data just because of the scalability and the size of the data. And security is the last thing here, but you know, ability to secure data for access at various levels of granularity is also important. And Starburst allows you to do that at catalog level, at the table level, row, column, and in some cases, using masking may be beneficial as well, because oftentimes what happens is that if there are no mechanism to do that, then organizations choose not to give access to the data, therefore limiting the ability to do analysis. But in many cases, this private information or sensitive information that needs to be filtered, it's not really used for analysis, like phone numbers, social security numbers, etc. So when you have this capability, it really opens up a whole set of other data that can be now accessible to the data scientists. And so here are some of the tools again that I used in the data science world. All of these tools are able to connect to Presto. And last piece to cover here is the benefits to the administrators. And so from administration perspective, ability to support the end users quickly in terms of adding data sources, I think that's a huge thing. It saves a lot of time for them and obviously shortens the life cycle. Ability to control the security in a single place with good auditing capabilities in place that allow you to understand who's using the platform, who's accessing the data, how long the queries are running for, and all of those questions all being in one place are very convenient. Scaling the cluster, of course, can be an undertaking if the platform doesn't support that natively. And so from Presto's perspective, and Starburst specifically, has the auto scaling capability. So again, it can scale up very efficiently and does have a graceful scale down algorithms that allow to shrink the cluster. So again, saving some of the dollars that are spent on the infrastructure. So all this kind of brings us to a point that there is a mind shift, which we advocate very much, is that shifting from sort of the single source of truth to a single point of access makes a lot of sense, because a lot of the times, despite the efforts to bring all the data together, organizations end up having some data outside of that data lake or data warehouse. And as I walked you through previously, there are a lot of benefits in enabling organizational access to data in this manner. So from here, just want to talk a little bit more about the architecture of Starburst and walk you through some of the most significant elements. So on the left-hand side, you can see the different organizational personas that can access data through the Presto cluster using JDBC or ODBC compliant tools. Now, on the right-hand side, you have all of the data sources that are configured for the cluster. They fall in a variety of different categories. These are cloud-based blob storage, for example, S3 compliant storages that are used on-prem or on the cloud. There are relational databases, data warehouses, non-SQL storage, and many other. And once these things are configured for the cluster itself consists of the coordinator that parses the queries coming in, performs some optimization, and then schedules the execution or the compute to happen on the worker nodes. Worker nodes have connectivity to the data through the central configuration, and all of that is accomplished through a prism of security. And obviously there are several elements here. The authentication mechanisms that are being used, Starburst supports Active Directory, LDAP, Kerberos, and auth is actually planned for the Q3 of this year. And the role-based access controls that I spoke about earlier, that giving you row level, column level data masking capabilities. And obviously all of these operationally is provided through a separation of compute and storage. So again, this concept is key when we talk about ability to scale and process data in a distributed manner. So to summarize it, the benefits of Starburst Presto fall in these categories. The performance is something that has been built into the product from day one. And not just latency, but also high concurrency. Those two things together is what oftentimes matters. And so Presto has really been good at doing that. Plus, there's also caching capabilities that some of the use cases can benefit from. Connectivity, we spoke about that, a whole variety of different connectors, and most importantly, ability to federate across them in a single query if needed is just cutting down the time and amount of data that you have to move around. Security is important with both authentication and authorization mechanisms that I described earlier. There's also ability to audit in the product, so you have a pretty good understanding of who is running which queries, what data is being touched, how much data is being moved or processed, and how long do those queries run. That's oftentimes very important for the organizations to have insights into that so that they can plan their infrastructure growth and so on and so forth. And then management, ability to quickly configure, easily maintain, easily auto scale, monitor the life cycle of the clusters, and also from deployment perspective, Starburst can deploy in a variety of different ways. It can go to the bare metal on-prem, it can be deployed into the cloud, can be deployed into the Kubernetes, which is actually a preferred way for us. We advocate that very much, but there's a whole variety of different ways to do that. And then last but not least, the support. As a commercial entity, obviously, we provided 24/7 support to our customers with all of the releases well tested, including the open source core that we test before we add it to our release. And needless to say that Starburst also employs a very large number of contributors to the open source Presto. So when it comes to Presto as an engine, there's probably no better place to ask questions than at Starburst. Just a couple of words about the use cases and how do we think about them from sort of the suitability perspective. So Presto being in-memory engine and being really good at low latency and high concurrency, it lends itself very well to interactive data investigations, and BI dashboards and reports are kind of a variation of that. They're not necessarily ad hoc. In some cases, they're well-known queries, but they fall more in that category than any other. The other one is, of course, the data science, and I described a little bit about the upfront need to analyze the data before you actually build the models, but executing the model building and training can also be used through Presto, especially in the cases where, again, low latency and high concurrency are of importance. It's not always the case, but sometimes it is. So in those cases, the data scientists can also benefit from ability to federate through the Presto. ETL is typically not something that we talk about a lot for two reasons. Number one is, as I said earlier, Presto really helps you reduce the need for ETL. But also, the truth of the matter is that ETL is still needed. Many times you are just doing aggregations, you are doing certain roll-ups and preparing the data shape that would be helpful in downstream analysis. And all of that can still be done through Presto. In fact, the other reason is that because Presto runs much faster, you're actually cutting down your costs. So if you compare, let's say, Presto with Hive, your ability to run Hive with ETL is well known. It's been done for years, and some companies still do that. There are certain benefits of Hive that make it a good fit, like resilience, for example, is oftentimes being noted. But what many people don't know is that Presto also has the same mechanisms available, for example, spilling to disk, so that you can have a resilient ETL process pipeline, but it's now running much faster because it's a lot more efficient. And so over time, your costs for the infrastructure are much less. So what I want to finish with is just one quick use case study. We work with Slack to help them with both analytics, ad hoc analytics, and ETL as well. So the challenges that they were facing when we started having the conversation with them is that they really had a high total cost of ownership. There was no auto-scaling capability available. Lots of time and effort was spent on managing and maintaining the infrastructure. And then at the end of the day, the most significant problem was the slow running queries and a very high failure rate. So they only were able to succeed with 50 to 90% of their queries getting through. And so once we understood that challenge, we helped them come up with the infrastructure that would auto-scale as well as shut down gracefully. So when the cluster is no longer needed, you could basically shut down the nodes that are taking up resources. Having a high availability coordinator was another thing that was put in place just so that the uptime of that infrastructure was higher and able to process a larger number of users without interruptions. Some of the security aspects were added into their infrastructure so they can manage security and access to data much better. And then finally, through the enhanced cost-based optimization, their queries were running way much faster than they were before. And again, most importantly, they were able to sort of fit their ETL into almost less than a second processing. They had a relatively large cluster, but in their case, they needed and had to process the data under these types of SLAs. So as a result, they were able to increase the success rate of their ETL completion. In fact, in this case, they still used spot nodes in the cloud, which allowed them to save costs even further. And again, some use cases are suitable to be used with the spot nodes because of the Presto's efficiency with a larger cluster like this, for example, makes a lot of sense because the spot node is not guaranteed to be part of the infrastructure. But if your queries are running fast and you're finishing your ETL process in several seconds, it almost doesn't matter. So again, this was the gains: the speed, the efficiency, and the success rate of their queries. And that's all I had today. So thank you again for joining the webinar, and we're happy to take on some calls, so questions.
Yeah, thanks, Sam and Martin. That was really helpful. So guys, if there's any questions, feel free to shoot those in the chat box. We actually have a couple that came through. Sam, maybe, I don't know, maybe you want to take this one here. How does Starburst Presto differ from other data federation virtualization tools that are out there?
Yeah, sure. So there are some tools out there that obviously do the federation and virtualization, and they're different things, but they're very related. Typically, virtualization is ability to bring the catalogs together into a single place, and federation is obviously ability to to join data across those catalogs. Many of the tools on the market take a slightly different approach. They bring the data and they essentially use caching techniques to prepare the data, bring it closer to the user, and make it more performant through those types of mechanisms. By contrast, Presto does it real time, and I did mention that Presto also has caching capabilities, but before even caching is turned on, Presto is very efficient with resource usage on the nodes. And through that, it's able to essentially scale without needing to bring the data close. And as far as the federation goes, specifically, again, in some of the other tools that are out there on the market, the data becomes available through a journey. You bring the data closer and you essentially make a copy of that data on another server, another database, and then enable federation across. Whereas with Presto, it's very natural and it's an organic. Those catalogs, they're mounted in Presto, but they represent a remote data source. And when you're federating inside SQL query, you're doing it live. You're essentially issuing a command that then goes and executes in a distributed manner, but it uses the original sources, and it's all happening real time. So that's the major difference, is just in the way that federation works.
Awesome. One more here. What are the most common data sources you see your customers deploying Starburst Presto against?
Well, commonality, I think, is a hard question to answer, but I think we're seeing a lot of trends. People using blob storage, S3, Azure, ADLS, the Google one as well. There are certainly still data warehouses in picture. In fact, a lot of the folks are moving to the cloud-based warehouses like Snowflake. Believe it or not, on-prem data warehouses like Teradata, Oracle, etc., still very much used. It depends on the industry. Different industries, you see different patterns. In finance, you've got a lot more on-prem databases. In marketing, you see a lot more cloud-based infrastructure. In fact, I spent most of my career in marketing, and I can tell you, even 15 years ago, we were using cloud and processing data in the cloud. That's not the case in healthcare. That's not the case in finance. So, I'd say all of the usual suspects in relational databases are present. A lot of the new cloud environments are present, and of course, there's some non-SQL database cases too. There's been a period of time about 5 years ago when they became very popular. A lot of people tried to switch to it for one reason or another. Some found it to be efficient, some found it not to be efficient, depending on the use case, but they are still very much in the picture.
Awesome. Any other questions from the group? Okay, great. So again, thank you so much, everyone, for joining the call today. Really appreciate you taking the time. Hopefully you were able to learn a little bit about Presto and Starburst's role in terms of enterprise deployments. We certainly recommend you download the O'Reilly book. It's in the chat window right here. We also encourage you to download our community version from starburstdata.com and try it out for yourself. So if there's nothing else, appreciate the time. And Martin, Sam, thank you for a great presentation today. Appreciate it.
Of course.
Thanks, everyone.
Thank you, guys.